These are the geometry 7.3 video notes part 2. So where we left off was we finished example 4. Now we're going to fill out this graphic organizer that says ways to prove a quadrilateral is a parallelogram. So the first way you can do this is by showing that both pairs of opposite sides are parallel. So that is the definition of a parallelogram. So if you can show that both pairs of opposite sides are parallel to each other, then you've got it and you've proven that it's a parallelogram. Another way is you can show that both pairs of opposite sides are congruent, meaning the same length. When you do that, you're using the parallelogram opposite sides converse. What that looks like is you have a parallelogram and you show that both pairs of opposite sides are congruent to each other. They are the same length. Your third way you can show that a quadrilateral is a parallelogram is you can show that both pairs of opposite angles are congruent. That is using the parallelogram opposite angles converse. So that's when the opposite angles are congruent. So that pair is congruent and this pair is congruent. All right, the fourth way you can show this is you can show that one pair of opposite sides, so just a single pair, is congruent and parallel. So it's a single pair, so they have to be congruent, meaning the same length, and that same pair has to be parallel. And if you do that, you're using the opposite sides, parallel and congruent, and that's actually a theorem, not a converse. And the last way you can do this is you can show that the diagonals bisect each other. Bisect means cut into two equal parts. When you do that, you're using the parallelogram diagonals converse. So what that looks like is you have a parallelogram, you have the diagonals, and the two diagonals cut each other into two equal parts. So this first diagonal is in two equal parts, and the second diagonal is in two equal parts. Not necessarily equal to each other, like the two separate diagonals, but like this one diagonal, the left side is equal to the right side, and then the other diagonal, the left side is equal, or kind of the top side-ish, is equal to the bottom part of the diagonal. All right, so like on this parallelogram, I see that you have a pair of opposite angles are congruent, and the other pair of opposite angles are congruent, because they're both 115. So that's showing that both pairs of opposite angles are congruent. So the theorem that I would use is the parallelogram opposite angles converse. So I would use the parallelogram opposite angles converse. Okay, on this parallelogram, you can see that the diagonals are marked. So you see this diagonal right here is cut into two equal parts. That's bisected. And this other diagonal with its markings are cut into two equal parts, and so that's bisected. That is the parallelogram diagonals converse. So you just really look at the image and the information you have, and you can refer back to this graphic organizer with the 5 ways you can show that a quadrilateral is a parallelogram. And this really helps me know which theorem or converse or definition I need to use to prove it. All right, and last but not least, we are using coordinate geometry here. So it's like on a graph paper is all that means. And it wants us to show that it is a parallelogram. There are lots of different ways to do this. Like we could show opposite sides are congruent using the distance formula. We could show opposite sides are parallel using the definition of a parallelogram. We can't really show the opposite angles. We don't really have the information to figure that out. We could also do one pair of opposite sides is parallel and congruent. So any of those work, but honestly, the easiest thing to do would be to show that the opposite sides are parallel. So let's start with side AB. So on AB, if you count your slope, I think they're parallel. I marked them just to kind of show you which ones I'm looking at. But I count my slope. So I go up 2 over 5. So the slope is 2 over 5. And now if I look at DC, then I go up 2 over 1, 2, 3, 4, 5. So the slope is 2 over 5. So right there, I know that AB is parallel to DC. Okay, so now if I look at the other pair of opposite sides, I'm hoping that these two are parallel right here. So that's what I'm going to check. So let's check AD. So starting here at A, I go down 3 over 3, which is -1. Now look at BC. Starting at B, I go down 3 over 3, which is -1. So we just showed that AD is parallel to BC. So I'm going to refer back to my graphic organizer to show you how I do this. You see I have this one that shows parallel, and it says show that both pairs of opposite sides are parallel. And if we can do that, we're using the definition of a parallelogram. So what I can go down here and I can say is I can say that ABCD is a parallelogram. I'm just going to use the symbol. And the reason why, the explanation is the definition of a parallelogram. So that graphic organizer really helps me explain why it's a parallelogram.